Hello folks, and welcome to Unit 8, which is Chapter 7 of Math 2201. Long course. Yep, they all are now. Okay, so we're talking about installment number 80. There's a lot of little videos we got going on here. So this is our 80th video, and in this 80th video we're going to talk about solving quadratic equations graphically. All right. So before we get into that, I should also mention that this is section 7.1 in your textbook. So we're at the beginning of chapter 7 here. We're going to talk about what is a quadratic equation. So what is a quadratic equation basically? How does that relate to what we already know about quadratics, which are quadratic functions, and how are they kind of the same? And then we're going to talk about connecting the solutions of an equation to the x-intercepts of a function. And that's a key for us in this first section. That's what this is all about. And then we're going to solve quadratic equations with a graph and see how that works. Sort of tell you a story about it, and then we'll do some problems in the next session. So what is a quadratic equation? Well, we know all about quadratic functions. We know something like this. Y equals ax squared plus bx plus c. That's a quadratic function in what we called standard form. Okay? So that was a quadratic function in standard form. A quadratic equation for us is going to be a quadratic in one variable. So we only have an x here. There's no y anymore, and the y has turned into a 0. So this is kind of the standard form of a quadratic equation in one variable. Now, when we change y to 0 and end up with an equation, that should really ring bells off in your brain, and you should be saying, "Hey, wait a minute, I remember doing that before." And if you wonder when you did it before, should come quickly to the back of your brain that that's when we were trying to find x-intercepts. Now that's going to be important to what we do in here in a couple minutes. All right, so there are lots of different forms that we can have for quadratic functions. We had a factored form and a vertex form and a standard form. And we can have those same things for quadratic equations. We can have a factored form of a quadratic equation, and that's a super important one when it comes to quadratic equations. That's the most important one. Okay. We can also have a vertex form, which was probably the most important one when we talked about quadratic functions. Not going to be as important here. We won't use it very much. Okay. And then we can have a scrambled form, which basically means any way we can jumble up any of those terms. And that's the technical mathematical term for it. It's called jumbled up. No, I'm just kidding. So we jumble up the terms, and as long as it can be rearranged to be a quadratic in one variable, then it's still a quadratic equation. Okay? So the main difference between a quadratic function and a quadratic equation, the way that we see it when we look at it, is that y has to become a 0. And we got to deal with that. Okay. So now we're going to connect what it means to solve a quadratic equation to a graph. And this is exactly what we sort of alluded to in the last slide there. If I'm solving the quadratic equation, x squared minus 3x plus 2 equals 0. Okay, so y's already been made 0. We have this. Well, as we said before, that's the same thing as taking the quadratic function with a y in it instead of just a 0 in it, this guy right here. Same as taking that quadratic function and letting it have its y coordinate equals 0. And what we find out is that if y equals 0, we end up on the x-axis. So graphically what we're talking about there are these x-intercepts. And if we're talking about the x-intercepts when y equals 0, then what we can think about is, if you remember what it means to be a solution to an equation. The solution to an equation is any value of x that we can fill in there in all the places we see in x that makes the statement that that equation is making a true statement. Well, those x-intercepts would give you the values of x right here that would satisfy the quadratic equation. So the solutions to the equation correspond to the x-coordinates of the x-intercepts. Now that's a whole lot of mumbo jumbo, or a whole lot of double talk. And basically all we're trying to get at here is a concept. What we did to find the x-intercepts of a quadratic function for its graph, where we made y equals 0 and we solved a quadratic equation without knowing that that's what we were doing. What we're going to do here is we're going to kind of work backwards. To solve a quadratic equation, we're going to think, okay, I know that that's something that has to do with a graph. If I can draw that graph and figure out what the x-intercepts are on the graph, those are the solutions I would be looking for my equation. So I'm just kind of working backwards. That's all that's going on here. Here's another example. Let's say I wanted to solve this quadratic equation right here. So to solve that, well, what I'm going to do is I'm going to remember that's really like a quadratic function, only y has already been set to 0. So let's put the y back in there for a second. And I'm going to ask my computer or my calculator or whatever I have at my disposal to draw a graph of that quadratic function. And it comes up with this. And then I look down here and I see, hold on, the x-intercepts for that quadratic function are at 1.5, halfway between 1 and 2 there, and right at 2 itself. So my x-intercepts are at 1.5 for x and 0 for y, and at 2 for x and 0 for y. All right. So then the third thing I do is I say I'm going to use those x-intercepts to state the solutions. So x equals 1.5. If I were to take that number 1.5 and plug it in here, that would make that equation work. Or if I were to take the number x equals 2 and plug it in, that would also make that equation work. So I have two solutions to this equation. And graphing is a bit of a sort of backdoor method to get at this to solve the equation, but it works if you have something to draw the graph for you, or if you know how to draw the graph by hand. Okay, so quick summary. Quadratic equations are any equations that can be written in this form. That's what we call the standard form of the quadratic equation. And the solutions of the equation correspond to the x-intercepts of a quadratic function. Kind of knew that already, but not really, because we never talked about it as a quadratic equation and finding its solutions before. A quadratic equation can be solved by graphing a quadratic function and just reading the x-intercepts from the graph. Easy peasy lemon squeezy if you have an easy way to get the graph. I hope that helps. We'll try to get some problems going on with this in the next session. Thanks.